So they never know my master plan. Okay, that's not very, well, you have it in front of you. Okay, so I have 2 logs that are the same base. And so I'm going to do the reverse of the product rule. I have 2 log statements with the same base separated by addition. I can combine those into one statement. Hey, get rid of that. Into one log statement. And when it's the product rule, when it's separated by addition, you have a product. So I'm multiplying the x plus 4 times the x minus 2. So it's the reverse product rule. When you have 2 log statements separated by addition, you can combine them by multiplying those 2 things. For homework, it would have looked like this, and you would have separated that into log base 2 of x plus 4 plus log base 2 of x minus 2. So this is the reverse.
Reverse what?
It's the reverse product rule. For homework, you were separating them. This one, you're putting it together. Now, in class, we did it both ways. Oh, both. That's what I say. I was trying to tell people I sound like a Yankee on this. And I said, I always say something Yankee, and it's both. Both. Who says both? Canadians. That's what happens. Okay, so now, both. Go ahead and multiply those 2. FOIL that thing out. Both of those. Multiply both. Both of those. Do your FOIL. X times x is x squared. Negative 2x plus 4x gives you 2x. I didn't show all the steps there. Now you're going to use your translating here. Log base 2 of that mess equals 4. That translates as... What? A sweet baby angel! I'm sorry, sweet baby angel. Class. Oh, wait. No. I want
us to silence our phones?
Now would be a lovely time to silence your phone. Sometimes I like to leave mine on and tell people to call me just for a reminder to the class to silence. Okay, there. All right, 2 to the 4th. Right, you're translating 2 to the 4th equals x squared plus 2x minus 8. And now you have an algebra 1 problem there. 2 to the 4th is 16. Move that 16 over and then solve it. Zero. X squared plus 2x. To move it over, you have to do minus 16, so you get minus 24. That factor's nice and pretty. When you're solving quadratics, you need a 0 on one side. That's why we moved that 16 over. We have a quadratic. So we're going to factor it and solve. 2 numbers you multiply to give you 24, but when you subtract them, you get 2, 6, and 4. And the big one is going to be positive. I know that because my 2 is positive. So the 6 is plus, and the 4 is minus. Set each of those 0 and solve. So your 2 answers to number 1, x is negative 6, or x equals 4. Okay, this one's just x times x minus 35. So you don't have to do FOIL, you just distribute normally. You have to translate at this point 6 squared equals x squared minus 35x. Move that 36 over and factor it. And you get minus 36 and plus 1. Those are the correct signs, because when I add negative 36 and 1, that's how I get negative 35. So I know I did it correctly. Set those equal to 0 and solve it. You get positive 36, but negative 1 for your 2 solutions. You guys are on the ball with that one. That was good. Good times. Okay, so we're going to skip to 3. Hitting record, I tell you. All right, so we did reverse quotient rule. And now we have 5 squared equals x plus 2 over x. So we have 25 equals x plus 2 over x. You cannot, for the love of all that's holy, cancel those x's. Weaves, did you just say that?
Yes, I was like, why can't we just cancel?
Oh, okay, because, yes, these are our handcuffs. You cannot separate the x and the 2. You cannot separate them. They're stuck together. You can't rip them apart and destroy what they have going to just hook up with this. Okay? Way to go. Way to, kill that sweet little math family. Okay, but you do have a whole number equals a fraction. You can cross multiply here. That's the easiest thing to do. You can change this to a fraction if you want. Changing a whole number to a fraction gives you just put a 1 on the bottom. When you have 2 fractions equal to each other, you cross multiply, and the 2 quotients equal each other. That's an old school math trick. So the reason I have to do that is because, God forbid, nobody in their right mind would cancel these 2 because we know better. And so that's the only thing we can do. We can't have x's all mixed up. So that's why we cross multiply so that it looks normal. Okay, so we cross multiply. But don't put them in a fraction together. 25 times x is 25x. Then put your equal sign. And put the other quotient on the other side. X plus 2 times 1 is x plus 2. And you're solving for x. So get that x together. And now divide by 24. Okay, it's not pretty. Nobody said it's pretty.
That's 12.
Oh, yeah, I went ahead and did the final answer. I'm sorry. Thanks.
Mm-hmm.
You redeemed yourself. So I reduced 2 over 24 to 112. Okay, so no quadratic here. You might be going, well, why don't we get a 0? Well, because I don't have an x squared. It's not a quadratic. I'm trying to figure out what x is. Get the x's together. So I'm going to move that 1x over. I'm going to do the opposite and subtract it. 24x's minus 1x gives me, 25x's minus 1x gives me 24. And to get rid of the 24, you do the opposite of multiplication. You divide. 2 over 24 reduces to 112. So that's that one. Okay, so again, we use reverse quotient rule. So we made a quotient. We translated 5 squared equals this. And then we did 5 squared is 25. Cross multiply. And then get x together. So that one's a little sassy. I'm going to let you stare at that for a minute and finish copying. And then ask a question. What are your questions on that one? Natural log. So now that you've seen that, you're going to remember it every time, right? You know natural log is log base e. Okay, so never forget. Never forget. And so now you just have plain old boring product rule. Put that together, which you all did. Distribute that 6. So e to the 0 equals 6x minus 6. E to the 0, anything to the 0 power is 1. And I moved that 6 over at this time, and that's how you get 7. And then get rid of your 6. So 7/6 is your answer, and you're going to leave it as just 7/6. Okay, that was good.